This problem still pulled up because the bell rang and I was kind of, I don't know what the word is here, but I was just not at a point that I could clear my head and get the information to you. So, now, in terms of this, I'm on the right page in here to refer to. Okay, we were talking about was the particle's acceleration. We found that to be the negative 15 halves. Explain the meaning of your answer in the terms of the particle's velocity. Well, acceleration tells you if the velocity is increasing or decreasing. Since it was a negative acceleration, particle's velocity is decreasing. Okay, and then it asks how would the units be explained in context to the particle. Okay, and at this point, what you're looking at is when we talk about acceleration, it's change in velocity over change in time, right? And we talk about velocity, what is a velocity unit? When we talk about velocity, it is distance per time. And so do we know a distance per time? No, we don't know. So, but the velocity would be distance divided by time, and then the change in time would be time, right? Well, think about this. If you do distance divided by time, so to divide by time, that would be multiplying by 1 over time. There's what you know, that this is going to be distance over time squared. Okay? Not time squared, time squared. Difference there. So when we talk about how would the units be explained in context of the particle, we're looking at, it's a distance of negative 15 per, 2, whatever our time units are there. Okay, so just a little bit about why our acceleration is the unit per time squared. Okay? Let's talk about a table problem. We've got table problems, graph problems, and calculator problems together. So we've got to book it. I've got to book it. Okay. So the table gives the velocity. Always pay attention, whether it's a table, a graph. What's in that graph? Or what's in that table? In this case, velocity. Table below gives the velocity in feet per second of a particle moving along a horizontal axis. The velocity v is a twice differentiable function of time t. Okay, so we've got the information. At t equals 0, determine whether the particle is moving to the right or to the left. Explain how you know. Easy question if you were here yesterday and remember what we talked about yesterday.
It was that.
Okay. At time 0, yes, at time 0, determine whether the particle is moving left or right. Explain how you know. What do we know at time 0? Velocity is negative. A negative velocity means that the particle is moving to the left. So v of 0 equals negative 4. So I can say at t equals 0, the particle is moving left. And I'm going to say since v of 0 is less than 0. Okay. Is there any time during the interval from 0 to 15 seconds when the particle is at rest? Explain your answer.
Yes. Between 2 and 3, there's a change in direction.
And how do we know that there's a change in direction between 2 and 3? Velocity changes from negative to positive. Now, this argument only works if this graph is continuous, if this function is continuous. Do we know for sure, because it was given as a table, so we don't have a graph to look at or an equation to look at, Do we know for sure that this is continuous?
No. Yes, because okay, I don't know what it is, but
Yeah,
6
because
could be
it's
2.
twice differentiable.
At 6 seconds of velocity could still be 2, or it could be 3.
Oh, yeah.
Oh.
What does differentiable mean?
That is
If a function is differentiable, it is thus continuous. Now, because this is, remember, continuity does not mean it's differentiable, but differentiable means it's continuous. So officially, if you just have this table of values, you don't know that this is continuous. I mean, yes, we can look at the fact, oh, it's it makes sense that it is, but you have to have a fact. Okay? So, you would want to state here, as part of your explanation, you need to point out that it is continuous because it is differentiable. That would be expected on a open-ended question. So v of t is differentiable. Just flying around?
Yes. It's
Okay.
right here. That's what I was doing whenever I was staring this way. So right here. I promise I was listening. Mario?
Okay. V of t is differentiable, thus v of t is continuous. You pointed out that v of 2 is negative 1. And that means the velocity at 2 is less than 0, yes? You pointed out that v of 3 is positive 1. That means the velocity at 3 is greater than 0. Now, it's been a moment since we've talked about this. Officially, there is a theorem that says this. And this is our intermediate value theorem. Okay, intermediate value theorem basically says if, this is continuous and this is at negative 1 and this is at 1, every value between negative 1 and 1 will be touched, so to speak. So thus we know it touches 0. Okay, so IVT is an official, answer here. IVT says there exists a time between 2 and 3 where the particle is at rest, or in other words, where the particle is equal to 0. So good to review those theorems. Intermediate value theorem.
A long time.
It has. So IVT, intermediate value theorem, write that down if you don't remember what IVT stands for, because you have to know it. There exists a time between 2 and 3 where v of t equals 0. So the particle is at rest. Okay. You guys all had the right idea. It's just I'm trying to make it official. Okay. See when you're ready. And I probably should have put C on the screen with this. I'll have to bounce back and forth because we'll have to look at the table. Actually, you know what? I'm going to leave C right there and I'll put my work in here in a moment. Use the data from the table to find an approximation for v prime of 8. Explain the meaning of v prime of 8 in terms of particle motion, so the computations that lead your answer and indicate the units of measure. Okay. How am I going to find v prime of 8?
Do we need to find the technically slope of that? Like taking the 10 and the 7 to get in between them?
Okay. So we can't do instantaneous rate of change here because we don't have a formula, right? But where does 8 fall? A time of 8 falls between 7 and 10, yes? So that's the best thing you can do there. We can essentially do an AROC, what's A stand for?
Average.
Average. Thank you. My mind just, I'm like, oh my goodness. Okay. Not instantaneous rate of change, the other one. Average rate of change. And so this is the idea of slope of the secant line, right? So it's using these values here. So using the fact that V of 7 is 3 and V of 10 is 5. And again, we can do this because 8 is between 7 and 10, yes? That's why we can do this. So, in order to do V prime of 8, I'm going to do V of 10 minus V of 7 over 10 minus 7. Or essentially slope is what your brains are thinking, right?
Yeah.
We are looking at slope. So fill your values in. V of 10 is 5 minus V of 7, 3 over 10 minus 7. So we have an answer of 2/3. Okay, what about units?
8%.
Yes, because it's only the first derivative, right?
It's first derivative of what?
Velocity.
Velocity.
Ah.
So velocity is
So
feet per second.
Feet per second squared.
So the derivative of velocity is feet per second squared. Okay. Velocity is always going to be units per time. Acceleration, the derivative of velocity is always going to be units per time squared. Okay. Let's see. We got our answer. We have our units. Explain the meaning in terms of particle motion. And we showed the computations. And we indicated the units. So, what is happening here?
Just increasing by 2/3 of the second squared.
What is increasing? You said it.
The velocity.
Okay, so a positive derivative to velocity, so a positive acceleration means that the velocity is increasing. Okay? So, just be careful of throwing in it, because I need to know what it is. Not to be nitpicky, but I kind of have to be picky. Do I want to know what Mario said?
I don't even know what mine is.
No.
I mean, I thought it was fine.
Okay.
Yeah.
Velocity is increasing at t equals 8 seconds. And I have it written as at about, and you can write it as this, 2 feet per 3 seconds squared. Okay, you can break it apart and write it like that as well. Okay, D. Find the average acceleration of the particle for 10 to 12 seconds. Explain what this number means in terms of the particle's velocity on the interval.
Use the same thing as it.
Pretty much.
But
Okay. Pretty much. You're doing the same thing we just did. Okay, just different values. So they're asking us for average acceleration. We're doing this on the interval from 10 to 12. Are those values that are provided?
Yes.
They are, aren't they? Okay. It's provided right there, so you have all the information you need. Okay, so traditionally, V of 12 minus V of 10 over 12 minus 10. What are my values? V of 12 is 3 minus V of 10 is 5 over 12 minus 10.
-1.
Negative 2 over 2, which is negative 1. Negative 1 what?
Feet per second.
Feet per second squared again. And what does this mean in terms of the particle's velocity?
Slowing down. Velocity is decreasing.
Velocity is decreasing, right? Velocity is decreasing at a rate of, well, I don't have to say negative here because I already said decreasing, yes? So 1 feet per second squared. I'm going to throw in, just for reference, because I have this written in my notes, you could also say 1 foot per second per second. Could they throw that loveliness in at you?
Probably. They all sound like jerks.
Okay, so just realize that 1 foot per second squared is the same as saying 1 foot per second per second. Just trying to make sure we got the equivalencies there.
You can throw a completely new word at you, but you have no idea what it means. So you're sitting there and you're like, I
Or
can't
throw
even
an
do this.
equation.
Can't even do this problem.
Florida,
I don't even know what derive is.
Or you do now.
What?
Yes, I do. Okay, I do know now.
I don't.
Okay. E. Let A of t equals v prime of t. So that's pretty much, that's standard, right? Acceleration is velocity, derivative of velocity. Is there a time t equals c, guaranteed, such that A of c equals 0 in the interval 0 to 15?
I'm just not going to answer the question because last time I got through it, I got it wrong.
C
So.
is taking the derivative twice, right?
Yes. Of position.
But we're given velocity, so it's just taking the derivative once. Yeah. Now, we can use information from prior parts here.
It's the same as B. It's continuous.
So we have to note, is this going to be continuous? Yes, because it was twice differentiable.
Then we got the acceleration of at 8 seconds. The acceleration between 10 and 12.
Are they just asking if it ever reaches a point where it's resting? Or where, not like resting, but like where acceleration is constant? No, not constant.
When it
Where-
is 0.
I don't know how to.
Where acceleration is 0.
Yeah, okay.
Okay.
Yes.
Is acceleration at 0 like cruise control?
Yes.
Okay. So acceleration is derivative of velocity. On part C, right here, we had what kind of answer?
Positive.
Positive. Here, we had an answer that was negative.
So it does.
This function is
Continuous.
continuous. So, will it ever be 0?
Yes.
Yes.
Yes, to go from positive 2/3 to negative 1, you have to pass through 0 because it's continuous. Okay? Okay. Let's see. First of all, make sure you state
Continuity.
that word. I don't know.
Words, I don't know that. I just make myself useful for something.
Okay. So,
You're smarter than you
because v of t is differentiable on 0 to 15, then A of t is continuous. Continuous or differentiable? I can't spell
I'm
differentiable.
struggling.
Differentiable is the one I've always like different. Like I have to say it in
You have to
syllables.
stretch it
I'm
out,
too
use your thinking.
tired. I'm like under the eyes of my.
Okay. Now, if I just grab the information that we had from above, v of 10 minus v of 7 over 10 minus 7. You don't have to show all the work, but we found that to be 2/3, which is greater than 0. We also did v of 12 minus v of 10 over 12 minus 10. We found that to equal -1, which is less than 0. Okay, so that's kind of your work. So I can say, thus, a of t equals 0 on the interval from 0 to 15. Oh, well, what do I want to say there? My answer key, I wrote 7 to 12. You could do this either way here. I originally just wrote 0 to 15. As I look at my notes, I wrote 7 to 12. Why did I say 7 to 12? Because specifically, ours is 7 to 12 here, isn't it? Now, does that also apply for 0 to 15? Yes. It does. Okay, so that's why, you could do either or, but specifically on 7 through 12, and that's because v prime of t changed from positive to negative. At some time. Okay.
Look at that. We got through a whole page.
We only got 2 more pages to go in half the class.
2 pages.
We got to
Great.
make it.
One of them is 800.
I wasn't.
Okay.
Dude.
Oh my
Right.
god.
We have a graph now. Always take a minute and observe. What is this a graph of?
Velocity.
So acceleration.
Okay. So velocity over a course of time. So the graph at right is y equals v of t, the velocity of an object moving on a line over the time interval 0 to 10. Assume that the positive direction is to the right. Okay. On what interval of time is the object moving to the right? How do I know when the object is moving to the right? When velocity is positive, yes? Since this is a velocity graph, velocity is positive above the x-axis, or the t-axis if you want to. So I'm going to say v of t is greater than 0 on 4, less than t, less than 10. I mean, really the answer is 4 to 10. Okay, B. When is the object speeding up?
Not when it's positive, but not
Like,
consistent.
Let's see.
No?
From 1 negative.
I was just going to say, what page number did Mario find for us yesterday?
isn't it
Speeding up,
positive?
positive. Yeah,
Or,
positive.
or negative?
Same sign.
Speeding up is same sign, slowing down would be opposite sign. So we need to talk about same signs.
2 to 6. And 8 to 10. Wait, no. Just 2 to 6.
No, 4 to 6.
Just
Oh, because it's under
Just 4
the.
to 6, right? Just 4 to 6. Because it's not anything that's
I haven't looked. I haven't agreed or disagreed with any answer. I was just writing that V and T have the same sign. So we have positive velocity up here, negative velocity down here. Acceleration is the slope. I think you guys already went through this. So we have a 0 slope, so that means nothing. We have positive slope, 0 slope, negative slope. So we are specifically looking from 4 to 6, as you guys discussed behind my back.
We always talk behind.
That sounds bad to say, but this time you were talking behind my back because I had my back turned on you, so I'll let you get away with it. So on my, let's see, how did I write this? On 4 to 6, since v of t is greater than 0 and v prime of t is greater than 0. So on the interval 4 less than t less than 6, since v of t is greater than 0 and v prime of t is greater than 0. Okay. How fast is the object moving at time t equal 3 and in what direction?
It is decreasing.
Going.
Well,
It's
-5.
decreasing at -5.
Okay, fast.
Going to the right.
How fast?
5.
We'll talk about direction here in a moment. How fast is the object moving?
5.
So positive 5 or negative 5? I'm hearing both.
Negative.
It's absolutely fine.
But it'll be positive because that's, I think I should.
Speed is absolute value of v of t. So if they're asking how fast is something, we are asking speed. So we want the absolute value of v of 3, which is the absolute value of -5, I don't even need to, which is positive 5, yes? So how fast is the object going? We don't have units here, so 5. What direction?
Left.
Left, because the velocity is negative. Well, and I'm going to say, you can either say moving left or moving in a negative direction. They assume, okay, they did specify left and right up there, didn't they? Or one of them, so you know the other. So moving left or in a negative direction, since v of 3 is equal to -5. So basically, since the velocity is negative.
3 parts down,
Or
5 to go.
v of 3 is less than 0 is what I wrote in my notes, I guess.
Right.
Okay. Average velocity?
Over 10 to 4.
What is the average velocity
It's 0 to 4.
over the time interval 0 to 4 and 4 to 10?
Not 10 to 4.
A-Rod?
I'm gonna say, could you take the points and
Oh,
find the derivative or slope of that? Find an average. So like, it's like 4, 0, and 6, 15. Same things.
You're right. I'm trying to make sure I lead us correctly.
What is she asking? So it'd be like 15 minus 0 over 6 minus 4.
She was just yapping.
I was just yapping.
Okay. When we talk about average velocity,
Would that be A-Rod?
Mhm.
No, it is A-Rod.
okay?
Average rate of change.
Average velocity, average rate of change. So we are looking at
Guys, that was it.
change in position over time
Right.
or displacement over time.
Mhm.
And I need a different page. I'm going to have to go back and forth between pages here. But when we think about that, change in position over change in time or displacement over time. Now, the tricky part about this is we don't have a position graph here, do we? We have a velocity graph. And that's what we have to be aware of. Okay? Now, we need to figure out what's going on from 0 to 4. And we need to figure out what's going on from 4 to 10, yes? The time is easy. Elapsed time is easy. Displacement. Okay? When we talk displacement, think, we want to think total distance. Okay? Again, we have a velocity graph here. So you are indeed looking at the area. Okay? If you go back and look at, I think that's on the page 2 there, isn't it? No, not in that. Well, yes and no. So, in this case, I have to go back. From 0 to 4, we need to talk area under the curve. Okay, when we talk displacements, area under the curve, what do you know here?
A triangle and a square. Yep, or that.
Either or. You can think trapezoid, you can think triangle and a square. Whatever information makes you happy there. What do we know?
The triangle is base times height.
Okay.
Or times 1/2.
So 1/2 base times height. What's my base?
2.
What's my height?
2.
Not 2. 10.
Oh.
I'm sorry.
1/2 times 2 times 10 is going to be
10.
10, because it's half of 20. And you can say me it is under there, so it is. You can think negative. What about this square?
20. 2 times 10.
That's 20. Let's go ahead and look at, we also have to look at what, 4 to 10?
Yeah.
What do you want to do with 4 to 10?
Probably just
A quadrilateral.
2 triangles and a rectangle.
You can do one big trapezoid,
Trapezoid.
or you can do
I don't
honestly, I don't remember how to do triangles.
Neither do I.
rectangle and triangle. So, FYI, for anyone that cares, you don't have to care because you can always do the triangle and rectangle thing, right? But area of a trapezoid is, I write it as 1/2 height times B1 plus B2.
Oh, just kidding.
Or some people write it as height times B1 plus B2 divided by 2.
4.
Okay. Now, what do you guys have here?
6 plus 2 equals 10. 8. I'm so sorry. Times 1, 2, 3.
I thought it was based on-
Oh, are you doing trapezoid?
Yeah, I am. I'm
Okay.
sorry.
That's why I was like,
You were
what?
thinking out loud.
No, you're all right.
It's 2 times 15 divided by 2 for one triangle.
So I see a 30 and 2 15s.
Yeah.
Trapezoid would have been 6
Plus 2 is 8.
plus 2 is 8. Half of 8 is 4 times the height of 15, which is 60. Okay. So, with this all in mind, down below, we basically had a negative 20 and a negative 10, which gave us a negative 30. Up on the 4 through 10, I had 15 plus 30 plus 15, which we decided is 60. Okay, that's our displacement. They asked us for average velocity, yes?
Mm-hmm.
So average velocity in the first interval, displacement divided by time. My displacement is negative 30 divided by the time, which is, what's the change in time? 4. Negative 30 over 4, negative 15 over 2, which is also negative 7.5. Whatever makes you happy there, right? Average velocity for the other piece. My displacement was 60, so that's the total distance traveled divided by a time of 6. 60 divided by 6 is 10. I don't have labels or anything on those because we weren't given labels for this problem. So,
4 down, 4 to go.
okay. And a whole other page yet.
Yeah.
Okay. What is the total distance traveled by the object? Show the computations that lead to your answer.
But even if you have negative 30 and 60, then it won't work.
You absolute value.
Oh.
But that would be
Well, and that's what it comes down to is yes, you need to think absolute value. I have, and I'm curious, I have in my notes page 145. Why do I have page 145? Okay, because that's where we talked about velocity versus time graphs at the time. Okay, that's why I have it. Why do I have it? Yeah, so.
Sorry. I'm so sorry.
So when we talk about total distance, we're looking at the area under a velocity versus time. For a velocity versus time graph, it's area under the graph. Okay, and that's what we had to do just back there on that one there as well. So. So, what did we know from 0 to 4? The distance was negative 30, but think absolute value. What do we know from 4 to 10? 60. And so that's going to be 30 plus 60, which is 90. I wrote in my notes here 90 units. If you don't have a label, that's, you can always throw in units. So for a velocity time graph, you're doing the area under the graph. Okay. Okay. When is the object slowing down?
2 and 4.
Yeah, between 2 and 4 and between 8 and 10.
Why?
Agreed.
Because page 144.
Okay. Up above somewhere we did when is the object speeding up, and we were looking for same signs. Now we are looking for opposite signs. So we want when V of t and A of t have opposite signs. So when we talk about opposite signs, I heard 2 to 4. 2 to 4 because what's happening from 2 to 4?
One's going up, the other one's like so it's
The velocity is negative, right? Because it is down below.
But the acceleration is
But the slope is positive, isn't it? Okay, because acceleration is going to be your slope. The other part, where'd you guys say?
8 to 10.
Okay. 8 to 10, my graph is above the x-axis, right? So that means my velocity is positive, greater than 0.
acceleration.
My graph is going down, it's decreasing, so that means my acceleration is less than 0. It's negative because there's a negative slope. So that right there is your answer. But justify is showing the opposite signs, okay? When is the velocity increasing?
2 to 6.
2 to 6.
Question.
Question mark.
Why 2 to 6?
Because it's crazy.
Why?
Okay.
Because it's right.
Because you're listening.
Because the slope is increasing.
Okay. We want, if the velocity is increasing or decreasing, is based on the slope, based on the acceleration, right? So Acceleration we want bigger than 0, so we're looking for when slope is increasing. Sorry, I'm facing you guys backwards. Okay, slope is increasing, and that is on 2 to 6. So I'm going to say velocity increases. I think they saved the easiest question for last, but that's my opinion. Maybe you guys won't see it that way.
Constant speed.
0 to 2 and 6 to 8.
Agreed.
On what interval does the object move at a constant speed? When is the constant speed?
0 less than 2, less than t less than 2, 6 less than t.
Good job.
What is the other one? 6 to 8?
Yeah.
Emma said cruise control earlier, right?
Yep.
Okay. You have a constant speed when you're on cruise control. You're not accelerating, you're not decelerating. Okay? You're just chilling.
Just
Right.
chilling.
Okay? It's the flat pieces on a velocity. Okay. Calculator STEM questions. Okay. An object moves along the x-axis from 0 to 6. The velocity of the object at time t is given by this fun equation, which is why we have the calculator allowed. For t equals 4, is the object speeding up or slowing down, and justify.
Slowly supposed to.
Oh my
Graph it or
Well,
This is nice.
I personally wouldn't graph it.
we need the derivative.
wait, what? No, it's a v of t.
Okay, so how do we determine speeding up and slowing down?
No.
You put it in there, but then you just do the absolute value around it. No?
That's fast. You're not that speed.
How do we determine if an object is speeding up or slowing down?
Oh.
Slowing down? Speeding up. We need to know the
Accelerate.
signs on
V of t and A of t.
velocity of acceleration. So we need to know, basically, what V of 4 is. You got a calculator in front of you, right?
Yep.
Plug it in. Now, I must say, I thought, there's really not a point this year in having the third set of calculators out. You guys all have your own. But I'm thinking you're finding convenience in just grabbing one of mine, aren't you?
Absolutely. Mine has been at home since we started school.
Okay. Do practice, guys. Although, you know what? I'm almost tempted to just tell you answers now that I look at the clock. Okay, I'm not going to plug in via 4. You guys are getting an answer, right?
It's taking me forever though, because I haven't used this thing in so long.
Where's LN?
Yeah,
LN is over to the left of 4.
4.496.
Yes, what he said.
Yeah. Sorry,
Used
guys.
to be like
You
a
guys are just
lose on
slow.
this thing.
80454.
Okay, calm down.
No.
No, it's like after the
Oh, okay.
5 decimal places.
Oh, I don't care about the 5.
Yeah, jeez, Mario.
It's taking me forever to get this.
It's not that hard.
You know, it even takes me a moment here, so.
Wait, what did you get? Did you get that?
Okay, you should have that.
4.4.
I got 3.11.
That's
Oh,
what
that's
I-
your
that's your- you got the LN.
Okay. Man, we should have done this differently.
Oh. Right.
Oh well. Because now we still have to find the derivative, yes?
Oh yeah.
So we need to know A of 4, which means in order to know A of 4, you need V prime of 4. Do I have to find this derivative by hand? No. You've forgotten because you haven't used the calculator in so long. Okay?
Yeah.
In your math menu, or it's also under alpha F2, we have inderiv. You want to use inderiv. We are taking the derivative with respect to x, so I fill in an x. Here, I fill in my equation. Not with a number, but I just fill in my equation.
Oh.
You guys have had this meeting again.
So So natural log of x, parentheses, minus 0.15 x.
Wait, you put parentheses around natural log?
It automatically puts parentheses around the first set. It automatically brings up a parentheses, so you have to close it.
Oh, okay, cool.
Oh shoot. Come on.
X.
And then we're going to evaluate this at x equals 4.
Oh, never mind.
This is taking forever.
I know.
Yeah, I'm realizing this.
Oh my lord.
Like no.
I'm still
Honestly,
making the whole equation right.
Neither am I.
Oh, that's what
I haven't either.
you guys are really slow.
Oh shoot. Crap.
Or they do the answer.
Whatever she
I
got.
still didn't
Second,
get
she
that
got
four number.
-2.
Oh my
Oh,
god.
thank God.
I'm not even doing it anymore. That was so proud.
Is this object speeding up or slowing down?
Slowing down.
Oh, yeah.
Slowing down because your teacher found that the signs are opposite.
Our teacher in the minutes.
And Kylie, thank you.
Oh, Kylie found it too.
Yes.
Now, okay guys,
Boys.
I said what we should have done. You had another option, which I didn't think about till we were already invested in this. You could have typed in the original equation in y1 in your graph. Not graphed it. But then if we had typed in the equation into y1, you could have said, okay, up here we could have just said, okay, I want to do y1 of 4. And that if you have the equation typed into y1, it would give you something. I don't know what I have in y1, but there you go. Okay. I also could have done the same thing if I do my inderiv.
I didn't have to type.
With respect to x, I could have typed in y1,
Oh,
evaluated
man.
at 4. It's not going to give me the right answer because remember, I don't have my y1 typed in, but we could have just typed in the equation once and done that. I didn't think that way. My brain is out of the loop with calculators too sometimes.
It's fine. It happens.
Okay,
This guy's deleted the
This
whole
B.
thing.
does make you feel old.
we are not going to get done, and that's a problem because I have us moving on tomorrow. Okay, a particle move. No, at what time on 0 to 6 does the particle change directions?
It's changed directions at the 4, right? Because it's acceleration. Actually, I'm just gonna be quiet because I don't think that's right. Yep.
No, at 4.
It's slow.
Okay, so when will a particle change directions?
Between 4 and 2.
No, general statement. When will a particle change directions? Forget this problem.
Whenever the
When it crosses
velocity
0.
goes from positive to negative.
So we're looking for velocity to equal 0. Okay?
Okay.
In order to find when velocity equals 0,
Why if you just take this
Is that equal to 0?
set equal to 0.
The equation that is now.
Set the equation equal to 0, yes.
Yeah.
How do we find those answers?
Inspection.
Inspecting what? Oh, you're talking, no. Okay, because we're looking at decimal answers, folks. This is a calculator STEM problem. So you're expected to use a calculator. I would have said, I don't have written in my notes how I did this. I would have said graph it. Okay. Now, now here's the thing. If we were smart and if I was smart and had already typed this in Y1, I could be using it for the 3rd time, yes?
You want
Teacher
mine?
fail. Okay? So here,
Fail.
I mean, I'll be honest, teacher fail here, okay?
It's fine.
This is what it should have looked like if you typed it in,
Yeah, it's so good.
okay? Now, with that in mind, sorry, it's all the blue is what's doing it, but how do we find when it equals 0, guys?
When it's
You can go
The
with
thing we did in pre-calc.
calc.
Trace.
Not even trace, go more specific. Zeros. Where is
Down.
my cursor?
Somewhere.
Okay, left bound, I'm below a 0. Right bound, I'm above it. There's a 0 at 0.391. Second, calc. Go to 0. How do I find the other one?
Down, right down.
Left bound.
Right there.
Right bound. There's one at 5.007. Okay? So, so I have v of t equals 0 at t is approximately 0.391. And that's because at that point my graph changed from negative to positive. Okay. The other place, v of t equals 0 at t equals 5.007. And that's because there my graph changed from positive to negative. Okay? Okay. Be smarter than me in that when you do something like that in homework. Put it in Y1 from the beginning and do everything through Y1. My fail. Learn from my fail.
T equals what? 0?
Okay. Do I have time to go through one more? Not really. Ugh. How rough is this going to make homework for you?
Not that rough.
I think we can figure it out.
Well, and here's,
We're smart.
you guys know what I'm going to tell you. Do the homework, right? Okay. Now, 5, 6, and 7. You can always take a picture of mine if you want, but her answer key is also available there, right? Her answer key is available there for the notes and for the homework. Try it, see what you can do, bring back the questions tomorrow.
I can't remember what time I'm leaving tomorrow right now, but I'm gonna try to save Miss J and we'll just let me take my lunch on the bus and then I can come to Cal.
So the email said 11:15, she's calling you out to go get dressed. At noon, you are leaving.
So can I maybe come in for a little bit?
That's between
If
you
I
and Miss
if I
J.
ask her, yeah.
Yep.
And just leave in the middle.
Here, real quick.